We are Team D&D Robotics, and we're presenting an automatic robotic palletizing solution for Premier's Tech Pet Food Bagging line. The goal is to replace manual palletizing with a safer, more consistent, and more traceable system. The current process depends on manual palletizing at the end of the bagging line. This creates ergonomic risk, inconsistent pallet patterns, possible shipping damage, and throughput limitations due to operator fatigue. Our solution automates inspection, rejection, palletizing, and level verification.
This is the 2D layout. The flow goes from the left to the right. The bags exits the bagger, the OML 1140, then it gets placed face up and passed through a metal detector and the check waiter. Each one has a pneumatic pusher. If it gets rejected, it goes through a conveyor, and that conveyor gets to a platform to stack like from a pallet, and then those rejected bags are picked up from the AMR P603 mobile robot, who picks them up and delivers it through a bad pieces area for the forklift. Then the good bags enter to the robot cell, and it makes the palletizing as requested from the RFQ. And finally, the finished pallets go through the print and apply and get verified at the vision cabin and exit at the outfit, ready for the forklift.
Okay, so regarding the safety design and risk analysis, we got the different categories that we had. All initial risks were either R1 or R2 in either of these categories, R2A or R2B, and we managed to reduce them to R3B medium or R4 low. There are some specific ones, like the perimeter guarding, like curtains, the 4E emergency stops, the energy isolation, the teach mode, and the AMR traffic control. Those added up were around 30 plus hazard assessed. We got the methodology right here. That is the ANSI Classic classification, which is the severity, exposure, avoidance, and risk classes. Also, we took into consideration the operating modes and the scope of the system. Regarding some major insights into the risk assessment, we got it that we avoided robot collision and crashing, conveyor entrapment, pneumatic reject pressure, gripper or vacuum failure, MRI interaction, or electrical lotto, or also implementation of e-stops.
As part of our proposal, we also designed a gripper that meets the requirements of the challenge. Ours consists of a metal cage that has two sliding pneumatically operated appendages. The first one slides up and down and is capable of grabbing bags and other amorphous objects using vacuum cups. Once said object is grabbed, the second appendage slides in and secures the object. The gripper's frame would be made out of 30mm square steel.
In regards to the robot selection, the ABB IRB 460 was selected because it's designed for palletizing. It has a 110 kilograms payload, 2.5 meters of reach, and 4 axes optimized for fast cycles. This makes it suitable for handling the food bags, the custom gripper, and the sheets placement.
So for the camera vision system justification, we used a Zebra V20 system that is mainly to detect label presence, to read the barcode of each bag, and to check the print quality of the system, because if not good detected or is not labeled correctly, it is rejected. Also, this is taking into account the whole integration system that, of course, is the smart camera and the barcode plus OCR kit that is given right here. The lightning was diffused LED. The trigger is a photoelectric sensor or on pallet conveyor. The PLC integration is alarm output to safety PLC, and the react action blocks outfit until operator confirms. This system integration costs around 60,000.
Here you can see the simulation. The simulation is the same as the 2D layout, but now in 3D. It all works with the same flow of 19 bags per minute to 22 bags per minute. You can see the mobile robot going for the reacted pallet, and then you can see also the print and apply and vision system. Finally, the forklift goes for both one forklift for the rejected parts and one forklift for the good pallets, and also that forklift can go for the bad, the rejected pallets. Now we go for the metrics and the results. We did 5 different cases of different conveyor velocities. So the best case was this one, that is 20 bags per minute through, the throughout of the bagger, and then the robot palletizes as 14 bags per minute. That is a 70% cell efficiency in steady state, and that means also that it palletizes 9 pallets per 16 minutes. Also, we have more bags in the palletizing of the small bags. So we had 3 of those, and finally 6 of the ones of the big ones.
So here we can see the vision system simulation in 2D, in its 2D version, and this is actually from the front view, and specifically from the print and apply system to the camera OC barcode and to the path of regular routing. We can see here that in the system is integrated at the end level presence barcode OCR, as explained previously, which through the PLC and all the sensors that were integrated along it, allows to a fail routing and to a pass system if the label is correctly detected, the barcode and the OCR.
Moving on to the finances of our proposal, the calculation of the ROI and payback time were dependent on the specific bill of materials we used. In the end, we decided on using the full bill of materials amounting to a total of 4.6 million pesos. This yielded a return on investment time of 13.2 years, achieving a 7.56% yearly return on investment. This was achieved through a difference of 870 pesos per day in daily replaced labor.
Regarding the client acceptance criteria, the design addresses the main client requirements for palletizing throughput, automatic method rejection, weight validation, pallet labeling, label verification, and safety compliance. These are covered through the ABB robot, reject pushers, check waiter, print and apply station, smart camera, safety PLC, guardian, light curtains, and emergency stops. This proposal delivers a safer and more consistent palletizing system. It reduces manual handling, improves pallet quality, adds inspection and label verification, and keeps the design cost optimized. The result is a feasible and scalable solution aligned with the client's RFQ.